Looking at the setup right now, what we're dealing with is more than just a winter storm. This is a pattern-driven winter event, and that distinction is important. A single storm comes and goes in a day or two. A pattern-driven event is different. It's backed by larger atmospheric forces, it has staying power, and it sets the stage for potential follow-up systems. So let's break down exactly what's happening and why this setup deserves your attention. The foundation of everything we're seeing right now is a deep Arctic air mass that has surged southward across the northern tier of the United States. This isn't just a quick shot of cold air. This is dense, established, sub-freezing air that is locked into place at the surface. Temperatures across the northern states are running well below seasonal averages, and this cold air is not retreating anytime soon. Why does this matter? Because this cold air mass is the foundation of the entire event. Any precipitation that falls into this air is going to stay frozen. We're talking about snow, and depending on the vertical temperature profile, we could be looking at higher snow ratios, which means fluffier, lighter snow that accumulates more efficiently. On top of that, wind chill is going to become a serious secondary hazard. The actual air temperature might be -5°C, but when you factor in the wind, it's going to feel more like -15. That's dangerous cold, and it's something people need to take seriously. Now, overlaid on top of this Arctic air mass, we have a developing mid-latitude cyclone. This low-pressure system is forming along what meteorologists call a baroclinic zone. That's just a technical term for a zone where there's a strong temperature contrast. And right now, that contrast is sharp. We've got deep cold air to the north, milder air to the south, and this low-pressure system is developing right along that boundary. When we look at the satellite imagery, we can see the classic signatures of an intensifying system. There's a spiral cloud structure. There are well-defined frontal boundaries, both a warm front and a cold front, and there's strong lift occurring along that baroclinic zone. All of this tells us that this system is actively going through cyclogenesis. It's strengthening, and as it moves eastward, it has the potential to intensify further. Here's the key principle to understand. The greater the temperature contrast, the stronger the storm potential. And right now, that contrast is about as sharp as it gets. Let's talk about what this means for precipitation. When we look at the radar and precipitation layers, we're seeing organized snow bands. These aren't just broad areas of light snow. We're seeing localized heavy cores, and we're seeing uneven distribution. Some areas are getting hammered, while areas just 20 or 30 miles away are seeing much lighter snow. This is a sign of mesoscale banding, which is when the atmosphere organizes precipitation into narrow, intense bands. If you're under one of these bands, snow totals can climb very quickly. We're talking about snowfall rates of 1 to 2 inches per hour, sometimes even more. But if you're just outside the band, you might only see light to moderate snow. This is why snow forecasts for events like this often come with ranges and uncertainty. A slight shift in where those bands set up can mean the difference between 6 inches and 12 inches. And on top of that, the track of the low-pressure system itself is critical. Small shifts, even just 50 miles north or south, can drastically change who sees the heaviest snow and who ends up on the edge of the event. Now, precipitation type is another major piece of this story, and it's not as simple as just saying it's going to snow. The thermal structure of the atmosphere right now is creating multiple precipitation zones, and each zone is going to experience something different. Let me break this down region by region, because it's important to understand which zone you're in. First, there's the all-snow zone. This is where the deep Arctic air is firmly in control. If you're in the northern tier states, the Great Lakes region, or the interior northeast, you're in this zone. Temperatures are well below freezing at the surface, and they're below freezing through the entire column of the atmosphere. Any precipitation that falls here is going to be snow. No questions, no mixing, just snow. The question for this zone isn't what type of precipitation you'll see. The question is how much. Second, there's the heavy wet snow transition zone. This is where temperatures are still at, or just below freezing at the surface, but there's some warming aloft. This zone typically sits just south of the all-snow zone. In this area, snow is still the dominant precipitation type, but it's going to be heavier and wetter. It's going to stick to power lines, it's going to weigh down tree branches, and it's going to be harder to shovel because it's dense. This is also the zone where we could see snow totals that surprise people because wet snow can accumulate very efficiently under the right conditions. Third, and this is the danger zone, we have the freezing rain and sleet risk area. This is the transition zone where temperatures at the surface are right at or just below freezing, but there's a warm layer aloft. When precipitation falls through that warm layer, it melts into rain, but then it falls through a shallow layer of sub-freezing air near the surface and refreezes. If it refreezes in the air, you get sleet. If it stays liquid until it hits the surface and then freezes on contact, you get freezing rain. Freezing rain is extremely dangerous. It coats everything with ice. Roads become impassable. Power lines snap under the weight of ice. This zone is typically narrow, but if you're in it, the impacts can be severe. And here's the problem. The exact location of this zone is highly sensitive to the track of the low-pressure system. A small shift can move this zone by 100 miles or more. Fourth, there's the cold rain zone. This is the southern sector of the system, where temperatures are above freezing at all levels. If you're in this zone, you're looking at rain, not snow. But don't think that means you're unaffected. The rain could be heavy at times, and once the system moves through, you're going to feel the cold air rush in behind it. Here's the critical point. Precipitation type depends on the vertical temperature structure, not just the surface temperature. You can have a surface temperature of 34 Fahrenheit and still get all snow if the air column is cold enough, or you can have a surface temperature of 32 and get freezing rain if there's a warm layer aloft. This is why forecasting precipitation type in these events is so challenging, and why small changes in the atmospheric profile can lead to big changes in impacts. Now let's talk about wind, because wind is going to be a major factor in this event. The pressure gradient around this low pressure system is tight. That means strong winds. On the northern side of the system, we're seeing strong northerly flow. That's the Arctic air being pulled southward. On the southern side, we're seeing moist southerly flow. That's the Gulf moisture being pulled northward into the system, but it's the northern side where the impacts are going to be most significant. When you combine falling snow with strong winds, you get blowing and drifting snow. Visibility drops to near zero in some cases. Roads that were plowed an hour ago can be covered again because the wind is moving snow around. And on top of that, the wind chill factor becomes dangerous. If the actual temperature is -5 Celsius and the wind is gusting to 40 miles per hour, the wind chill can drop to -15 or even lower. That's cold enough for frostbite to occur on exposed skin in just minutes. This is serious, and it's something people need to prepare for. The track of this system is something we need to keep a very close eye on. This forecast has high sensitivity to track adjustments. What does that mean in practical terms? It means that if the low-pressure system tracks 50 miles further north than currently forecast, the heavy snow zone contracts. More areas see a mix or rain instead of all snow. If the system tracks 50 miles further south, the heavy snow zone expands. Areas that were on the edge of the event suddenly find themselves in the bullseye. This is not unusual for winter storms, but it's something people need to understand. The forecast is not set in stone. It's going to evolve as we get better data and as the system actually develops. So if you're following this, don't lock into one specific outcome. Stay flexible, watch for updates, and understand that adjustments are likely. Let's zoom out and talk about the bigger picture, because this event is not happening in isolation. When we look at the upper level dynamics, we're seeing an amplified jet stream. There's a deep trough digging southward, and that trough is funneling Arctic air down from Canada. On top of that, there's potential for a blocking pattern to develop, which would lock this cold pattern in place for an extended period. What this tells us is that we're not just dealing with one storm. We're dealing with a pattern shift. This is the kind of setup where one system moves through, and then a few days later, another system develops and follows a similar track. The Arctic air supply is persistent. Below average temperatures are likely to continue for a while, and the potential for additional winter weather events remains elevated. So when you're thinking about this, don't just think about the next 24 to 48 hours. Think about the next week or even 2 weeks, because this pattern has staying power. So what are the main risk scenarios we need to consider? Let me lay them out clearly, because depending on where you are and how this system evolves, you could experience very different impacts. Scenario A is a heavy snow event. This is the scenario for areas in the all-snow zone. If you're in this scenario, you're looking at significant accumulation, possibly 8 to 12 inches or more in the hardest hit areas. Travel is going to be dangerous or impossible. Snow removal is going to be ongoing, and you're going to be stuck in that cold air for days afterward. Scenario B is ice accumulation in the transition zone. This is the most dangerous scenario for some areas. If you're in the freezing rain zone, even a quarter inch of ice can create major problems. Power outages become likely. Roads become sheets of ice. This is the scenario where you need to be prepared to potentially lose power and heat. Scenario C is wind-driven impacts. Even if snow totals are moderate, if the wind is strong, it's going to feel like a blizzard. Blowing snow reduces visibility to near zero. Drifts make roads impassable even after plowing, and the wind chill becomes dangerous. Scenario D is a prolonged cold outbreak. This is the scenario where the immediate storm is just the beginning. The cold air sticks around. Additional systems follow, and you're dealing with a week or more of below-average temperatures. Scenario E is model adjustment risk. This is the scenario where the forecast shifts significantly as we get closer to the event. Track changes, intensity changes, timing changes. This is why staying updated is so important. The core message here is this. We have strong Arctic air in place, a developing baroclinic low-pressure system, and a high-temperature contrast that's fueling intensification. Snow banding is possible, which means localized extreme totals. There's ice risk in the transition zone, Wind chill is a secondary but serious hazard, and the pattern is likely to remain active beyond this one event. This is a complex, high-impact setup, and it requires preparation and attention.